Okay, so hello, I'm Meng from Unity. Today I will introduce to you Unity URP 2021 LTS Feature Showcase. As we know, on April 12th we released Unity 2021 LTS, and it incorporated 2021.1 and 2021.2 in respect of all of the new features of the engine, and all of the functions had gone through 6 months of testing, so you can rest assured while using the highly reliable workflow and stable all cross-platform game performance of 2021 LTS. So let's watch a video so that you can get to understand the highlights of 2021 LTS. Can you help me play the video?
OK，
Okay, through the video, you can find that we made a lot of improvements in 2021 LTS in a simple workflow, building high quality content, optimizing graphics capability, and improving the platform support. But today, I will introduce to you about the Unity General Rendering Pipeline URP and the new features in the 2021 LTS, and I will demo you how we use the new functions. So let's go on. Unity 2021 LTS incorporated Unity 2021.1 and .2 in respect of the 20 plus new features in the URP. For example, the render pipeline converter, decal system, deferred render path, light cookies, and reflection probe blending and box projection, and so on. Besides that, we have 13 modifications and 60 bug fixes. If you want to know more, you can visit 2022.3 release notes. Uh, this is the link. So the first feature is about the upgrade to URP, the internal rendering pipeline to the general to the universal rendering pipeline. So compared to 2020 and the previous versions, it's different. There's a new render pipeline converter. So it's a new converter framework that moves the internal rendering to URP. So the overall upgrade is more stable, and it supports the conversion on the elements other than texture. So the render pipeline converter can help us provide informative upgrade progress feedback, and while watching the list we can get to understand which assets can automatically upgrade and which assets can get affected uh, by upgrading to URP and needs manual interference. And during the manual workflow, the converter can also provide us with some upgrade guideline and manuals. Plus, the pipeline converter can act as the container of the converter, and it allows users to select the converters that they want or don't want. For example, we can choose the animation clip converter, or we can not select. We can remove the read-only materials converter. So this is a robust and scalable system. The developer can very easily use the upgrade and use the UI UX. For example, a team wants to create an upgrade program for GI Bake so that they can easily add that to add the converter to the workflow.
软
What's
件里
more,
面有像
we do
render
have the
settings、
render
Level、
settings, material,
Material、
read-only material, and animation
Clip
clip
Converter。
converter.
那么另外关
And
于
plus,
PPV2 的一个，也就是内置
for
软件端起的一
PPV2,
个
built-in
后处
post-process
理的一个
converter
后处理的一个端起，以及我们
and
shader
the
一个
shader
端起的话，应
converter
该也应在
are now in
测试
the
里边
test
应用很
phase.
快也会
I believe
大家
that you
能
will
能
see
体验
them
到。
very shortly.
那么接下来这是
Next,
一个就是我们如何使用
this is how we use
我们如何使用我们
this is
软
how
件
we
端起来进行
use
升级。
the
那么首
pipeline
先要注意
converter
的
to
一
upgrade.
点就是
So first thing to
整个
notice
转
is
过程的
that
话，它的更改是不可
the
逆的，所
change
以我们
during
在转
the
换前的话，我们
conversion
会对
is
照一下我们的
irreversible.
项目。
So we have to copy our
那
projects.
么首先的话，我们要在一个 URP 的
In
过
a
程中导入
URP
我们的一个
project, we
备份
need
软件素
to
材。我们打
import
开场景的话，
the
我们会
asset
发
of
现，
the internal
这
pipelines.
个不是由于
If
装
we
置
open
不
a
够，
scene, we
而
know
导
that
致我们的一个
during
材
the
质显示
mismatch
一个
of the
枯燥。
shader,
那么怎么解决呢？
the
那么之前老的
texture
版
is
本中的
shown
话，我们
pink.
可以
So how
在
to solve it?
Edit 下
In
面
the
找
old
到我们的
URP,
Rhythm Pipeline 上面去
under
变
edit,
化。
we
那
can
么在新
find
的版
the
本中的话，
render
我们
pipeline to
要在
convert.
我们的 Windows
In the
下
new
面
version,
找到我们的
in
一个 Render Room，
Windows, we
然
should
后
find
找到
rendering and
Render
then render
Pipeline
pipeline
Provider。
converter and open that.
然后打开我们的一个
And
渲染委员端起。
we open the render
打开
pipeline
之后的
converter.
话，我们在这里面
The
我们要选择转换的类
inside
型。
the
这边的话，
converter,
我们
we need
选
to
择应用模
choose
式，打
the
算
type
从
uh,
Building
from
URP 进
built-in
入
to
到了
URP.
Building to URP。 那么根据转换类
And
型的话，那
according
么
to the
右上
type of
方
the
面会显
conversion
示
in
我们
the
可以用的一些转换器。我们可
conversation,
以
it
选中
shows
前面的资源
available
包，来
converter.
开启
So we
对应的一个
can
转换器。
tick
那
the
么
boxes to
可以看到
open
这里
the
有
relevant
关于
converter.
渲染设
So
置类型
here
的
we
话，
have
有
the
关于材质
conversion
的，
of
有
the
关于图画变
rendering
量，以及
configuration,
直播材
the
质的一些转换。
texture,
那
the
么我
animation
们
clips,
点
and
击
read-only
初始
material.
化转
So we
换，
can
就把它给
initialize
选
the
上。
converter. So we pick all of them.
初始转换完成之后
So
的话，我
after
们点
the
击
ticking,
我们的这
we
个初始
can
化转换。
click initialize the conversion.
那么点击完初始化转换之
And
后的
after
话，
clicking
那么
that,
渲染管线会根据我
the
们
rendering
根
pipeline
据预处理项目的一
will
些资产，然后就
pre-process
显示
some
我
of
们
the
要
assets
转换
in
的这
the
些列表。那么
projects
选
and
用或者
display
精
the
读
elements
资料旁边
that
的
we
一
need
个地方的
to
话，可以在这个转换
convert.
中启用或者
And
取代
we
它。
can choose or unchoose the boxes and
那么
enable and
元素
disable
旁边的
them.
一些黄色的一些图标可以
And on the right side of those elements, you see that the yellow icon, which means it requires your manual operation to start the conversion, and you can hover your mouse on that icon to see the description of the issue. So we convert assets, we click on that. Now we have successively converted our internal model into an URP format. Let's continue. And next is the URP, new decal system. And decals means we can add on the surfaces of any kind, some detailed, such as the static ones, such as the bullet holes in an FPS games or the stains on the floor, graffiti on the walls, etc. And apart from these dynamic ones, we are allowed to add the dynamic details. For example, some artificial fake shadows or dynamic textures, just like you can see on picture number 4. And the URP decal system also support some adding physics-based lighting to the surface of those objects. And because decals is one of a very common feature in modern games, many users will give up using URP due to the lack of decals in URP. And so some users, though, will write their own solutions for that because this is not in the pipeline. But to have a high quality decal system, it's not that easy because it is related to the rendering logic. So URP has its internal decal solution. This is quite important. And Unity have modularized the decals in our render features with URP version 12 and above, and achieved the decals projector to have the decal shader graph to increase the efficiency of creating decals by the developers. And URP covers many platforms. That's why we have launched 2 different solutions so that the users could choose accordingly to choose different quality and performance decals solutions. The first one is screen space decals. Well, after the or behind those non-transparent objects rendering those decals, though visually it's limited, but it doesn't need that depth prepass, which means the screen space decal solution is very suitable for the tile-based rendering devices, which means it's suitable for mobile devices. And another one is the decal buffer solution, which is similar to the G-buffer decals. Unity will render the decals into the D-buffer, and the Unity also, when rendering the non-transparent objects, will cover the debuffer contents on the surface of the non-transparent objects. The debuffer decal solution requires the depth normal prepass, so that this is slightly less efficient on these tile-based rendering GPUs. So it's not that suitable for the mobile platforms, but pretty good for PC and a console. And our high-definition rendering pipelines HDRP currently uses this decal solution. URP also supports the instancing of GPU and the ECS subset system. So if within a scenario the decals uses the same texture and it had toggled on the GPU instancing, then URP will instance that texture and reduce its impact on performance to save time for rendering, as well as the integrated batch numbers. And apart from that, the URP decal system has used an achieving method similar to ECS. So if it is used together with the Jobify and a burst, the performance would be even better. And here I have a simple test. In our scenario, we created 10,000 decal. And after using burst, we can compare it with before. In Profiler, we do see that after using burst, the function's consumption got much less and the frame rate got improved, and we don't see many the ragging glitches. The URP decal system currently do not work on transparent surfaces, but in HDRP, we have already achieved that with cluster decal. So our future plan is to transplant the HDRP decal solution to URP, so that it could also adhere that friendliness with mobile devices. URP as our mainstream rendering pipeline, its functionality is getting closer to the internal rendering pipelines and will eventually replace the internal rendering pipelines. That means we need to add some functions that internal pipelines already supported, but URP hasn't been able to do so. And delayed rendering function is one of that. Great news is that with URP 12.0 and the latest, even later versions, we have supported that. And you can enjoy that with Unity 2021.2 and versions published after that. Well, delayed or deferred rendering can become a solution for a large number of lights because it can separate the geometrical path with light path and use the same resources to render more lights, and it's now widely used. For example, the Made with Unity, a great game made with Unity, Genshin Impact has used this deferred rendering path. And on the other end, URP is dedicated to provide a rendering pipeline which supports all available platforms, including the lower-end mobile devices to premium and desktop PCs. And that means adding deferred rendering into URP would have to require us to explore different methodologies to solve the problem of the differentiations between these target platforms. Currently, not a single perfect deferred rendering algorithm can actually meet that requirement posted by multiple platforms. But stencil-based, the classical one, and the tile-based deferred rendering algorithm are the two mainstreams. And as two algorithms of those, how are they achieved is not going to be the main point of our discussion today. Let's see a set of experimental data. In the same scenario, based upon these two solutions, when compared with the internal rendering pipelines on different platforms, here you can see one scenario with a one directional light and a 64 point lights. And the illumination mode is baked lighting, and it runs on NVIDIA GFX GeForce 1050 and the iPhone 8 A11 Bionic devices. And you can see that the URP deferred rendering technology is better than the internal rendering pipelines. And also the two deferred rendering solutions on URP also has its advantage or disadvantage on mobile and desktop respectively. And it's worth noting that when after choosing the deferred rendering path, Unity will show the accurate gbuffer normals attribute. With this, you can define how it's going to be stored in the gbuffer and how do you code that gbuffer. So let's take a look the function of that. When closing or shutting down the accurate gbuffer normals, it can help you to increase performance, especially on mobile and the GPU, but causes the color bands happening on surface that are pretty smooth. And when you switch on accurate gbuffer normals, Unity will use the octahedral encoding to store the value of the normal vector in the RGB channel of the normal texture. Now let's see how do we switch on the deferred rendering path in URP. Let's see, edit, then project settings, URP assets allocation, and then renderer. Choose the rendering path as deferred. And after doing that, we run the following scenario. Let's take a look. In Window Rendering, then Light Explorer, you can open up the Light Explorer window. This window allows us to see, to choose and edit all of the light source information in scenario. There are 60 dynamic light sources in this scenario. If it is front-end rendering, the performance would be much lower, but the deferred rendering is definitely a solution for those large and complicated lighting scenes. However, deferred rendering is not going to solve all of the problems. It's not omnipotent. It's still got some limitations. What are those? First of all, it lacks of the anti-aliasing support. Although we can use the screen space AA algorithm, but it doesn't show a very good performance. Another issue is related to camera stack. Only base camera are allowed to use the deferred rendering mode. If you want to render the overlay camera, then it must be switched back to the front end rendering mode. So is there a way to solve the problem of that, to overcome the limitation of front-end rendering and the deferred rendering, but still has that ability to treat multiple lighting sources? Well, we have to mention about the next generation multi-lighting rendering technology, Forward Plus. It's a plugin of the Forward because the technology is similar to the Forward front-end rendering technology in terms of the non-transparent and transparent path, but it's not going to have a loop to traverse the entire scene, all of the dynamic lightings, but only consider the current space within your screen and the lighting within that limited area. It's also a tile-based front-end forward rendering, and deferred rendering technique is combined together with its advantages, so that we get to eliminate some of the limitations with deferred rendering techniques to have better pixel qualities. Currently, the Forward Plus technology is still in an experimental phase, but soon you'll be able to enjoy the official version of it. And how do we switch on the Forward Plus rendering mode for a scenario? We have to find project settings and then player, then scripting, compilation. You input URP, enable clustered UI, and click on apply. Next, we find the URP project relevant renderer. In that rendering column, you can see another new option had occurred, which is clustered experimental. And after you click this on, you can open Forward Plus rendering mode for your project. And the next, the real-time GI. Real-time GI is a technology which allows the interactive updates with illumination in scenarios, which is different from static textures with illumination, because it doesn't respond to those changing lighting conditions. But with Enlighten Realtime GI, it is suitable for those slow changing but highly visible light changes. For example, the sun moves in the sky, or if it's the light shining and the blinking in a closed hallway. But due to performance cost and the delay, and the real-time GI just cannot serve that. So Enlighten could solve that, and also it's a great solution for baked GI as well. And in order to reduce the difficulty for user upgrading to the universal rendering pipeline, so that more people could use URP, in above 12 versions, we have added the support for Enlighten Realtime GI. So you can see that with version 2021.2 or later, you can use Enlighten Realtime GI in the three main pipelines. But before that, we currently do not support it in Enlighten Realtime GI in the SRP. And for real-time GI, it is more suitable for the mid-level to high-end PC systems and consoles, and for some high-end mobile devices, if its computation power is strong enough, it could also use this function as well. But here, you need to pay attention that we should keep the scenario as small as possible to reduce the real-time GI textures resolution in order to save the precious system assets and resources. In order to enable Enlighten real-time GI, we have to click on Lightning and then click on real-time global illumination. And in order to disable it, we simply just click to disable it. Another two functions I'd like to mention about, the first one, reflection probe. It's very much like a camera, which captures the vision of a scenario from multiple directions, and the captured pictures would be stored into a cube map, could be reflected by those objects with the reflectivity. For example, on the left side, you can see once the scenario, the room is built and the reflection probe is added, you can see that on the surface of that glass of the book cabinet, you can already see those reflected information of the floor. Normally, in order to achieve better realisticity of the scenarios, we may set up multiple reflection probes, and that means we have to talk about the first function of it, reflection probe blending. It can do the interpolation between different reflection probes in order to have the reflection changes, which is gradual. Just like you can see from the video, from one reflection ball to the other, this type of design makes sure that once your object goes through the boundary of one reflection probe and goes into the scope of another, you wouldn't see a glitch in between.
So I want to play the video. And next, let's take a look at another new feature. We note that in the indoor scene, the closer the object is to the wall, it gets more reflection to the wall. The further, the less reflection. So how do we realize that in Unity? In URP 12.0, we have this box projection to allow the object to display different levels of reflection according to its distance. So let's take a look at the sample. On the graph on the right side, actually that's an iron door. So on the reflection information on the hood, you can see that, right? So we didn't open the box projection, and you can take a look at the information, the reflection information on the hood, and this is on and this is off. So according to the distance of the lamp to the door, you can show the different information. So this is box projection. So how do we turn on box projection? First, in the previously created URP asset, in lighting reflection probes, we can tick box projection. Then we need to find the matching reflection probe. In inspector graph, you need to find the box projection under reflection probe component. We need to turn on both. So how do we turn on refraction probe blending? So first, just like before in the URP asset, in lighting reflection probes, we need to tick probe blending, and we need to find the reflection probe, and then in the inspector we need to go to reflection probe, and then in the blend distance we need to set it above 0. If it's 0, then it means it's disabled.
OK，那么接
And
下来是另外的一个新功能，就是镜头光晕，就是
the
NSPL。
camera
那么镜头光晕的话是模拟相机
lens
正常映
flare,
射射光
that
片的一个效
means
果，
it's
在
the
游戏运营
effect
中
of
是比
the
较广泛的，比如说
diffraction
可以表达
of
一些
the
明亮的
in-game
光线，
camera,
然后
so
玩家
it's
的
widely
视野
used.
为
That
游戏
means
场景添加一
bright
些美
light
妙的气
goes
息，给
across the
玩家
field
营
of
造
view
一
of the
种
player, so it
身临其境
adds
的一
to
个
the
感觉。
atmosphere of the gameplay, and it creates this kind of a very immersive
那么与
environment.
内置渲染管线的其
And
他
it's
冒险
different
中呢
from the
，URP 12
implementation
代
of
中采
the
用了新的一
internal
个
rendering pipeline
NSPL
in URP
SRP 的一个技术，
12.0.
来
There
实
is
现
the
相同的
lens
镜头
flare
光晕。
SRP
那么虽然
to realize
NSPL
the lens flare.
组件为内
Although
置
the
渲染
lens
管线的
flare
一个 NSPL 组件
can
可以实
realize
现
the
同样
same
的效果，
effect
在
compared
内
to
置
the
渲染
lens
管线中。
flare with the in
但是内
the
置渲染管的
internal
NSPL 组件
rendering
并不兼容
pipeline,
我们主
but
线
the
渲染。
internal rendering
那
pipeline's
么
lens
用
flare is not
12的话是
compatible to
URP
the
中的一个 NSPL 系统
programmable
暴露
rendering
出了
pipeline.
比之
The
前
other thing
更
is
多的
that
一个风险。
URP lens flare
这个
exposed more
用到
parameters.
最右边的图，
You can
它暴
see
露了更
the
多的一个参
picture
数。
on the right,
并且 URP 中的一个
and
SSAO
the
系统
URP
中
lens
添加
flare
了许
system
多镜头
incorporated
光
a
晕的
lot
一个
of
预设体验在
preset
里面。
curve of lens flare,
那么艺术家们只
and
需
the
要去调节
artists
这些
only
预
need
设
to
预设体
set
现的话，就可
and
以创
tune
造出
the
效果
preset
亮一点的一个
flares,
镜头光晕。那
preset
么所以说
curves
对于艺
to
术家来说
create
是非常友好
very
的。
beautiful
那么
lens
最后
flares, so
的
it's
话就
very
是
friendly to the artists.
新版本
And
中
the
的
other
一个
thing is
SSAO 系
that
统
the
是
new
基于
version lens
深度
flare
和
is based
是
on
基于深度的，而
is
且是
doing
我们
the
可以进行一
occlusion
些
and
遮
culling
挡和
based
释
on
出，
the depth.
所以我们
So
不
we
需
can
要
do the
再
occlusion
去
and culling
像内置渲染管
without
线那样去依赖一
relying
些
on the
layer。
collider. So I will just go through it very fast.
如何去做一
This is how
个
we do
lens flare。
the lens flare. So I'll just go through this one.
我们来看一下是如何
So let's take a look
在
at
URP 我们在英语中的话是如何实现我们的
how
lens
we
flare
realize
这样的一个效果。
this effect.
OK， 我们首先的话，我们要找
First,
到我
we
们
need to
场景中
find
的一个光源，
the light
并
source
且添
of
加
the
一
scene,
个镜头
and
光
we
晕
need
系
to
统，就是
add
lens flare。
the lens
然后
flares.
这里的话，我们点
And
击
here
我
we
们的这个
can
平行
click
光，就
the
是
direction
direction
light,
在
and
Inspire界
in
面中的
the
话，我们来添
flex
加一个 lens flare 这
inspector
样的一个 SRP 这样的一
graph,
个图
we
片。
need to add
接
the
着
lens
我们
flares
还需要
SRP,
创建 lens
and then
flare
we need to
data，
create lens flare data
为它配置一些数据。
and
那么我们
have the config data set.
我们创建一个 data， 然后接下来我们要
So we
把
need to create
这些
that
数据，
data,
我们可以看到
and
这我们在这个配置数据里面的
you
话，
can
我
see
们要
that
添
in
加
the
调
config
整
data,
编
we
辑
need to
相应的
add,
一些基础元素。
adjust, and
那么因为
edit
镜头光晕的
the
本质的话，就是
texture
多面
element.
片按
So
照
since
设定的一个顺序
lens
大
flare
小叠加出
basically
来的效
is
果。
the
那么
overlap
我们
of
可以看到
different
lens flare SRP 暴露出了
faces
比 built-in 更
according
多
to
的一
certain
个镜头光晕效
orders.
果。
So lens flare SRP
我们来看一下
exposed more than the built-in, more data than the built-in to realize the lens flare. So we can run it. It's a bit blurred. So can you switch the slides for me?
OK。 那么接下来就是
Then
light
light
cookie。 那
cookies
么它是一种使用
It's a
2D 能力
kind
或者说 Cube Map 来实现
of
遮蔽或
method
者过
to
滤
use
无色光
2D
来产生
texture
图案的这样
or
的
cube map to realize
效果。
occlusion
它可以
or
更改图的
filtering
外观颜色、
to
形状、强度。那
to
么它是
use
模
it
拟
to
复
apply
杂
it
光的
on
效
the
果的一
projection
个
light
效
to
果方
create
式。那么
the
并且
the
对
graphics,
运行时
and
的一
also
个
it can
性能影
change
响十
the
分不优
projected
的。那么我
light's
们可以使用
color,
来模
shape,
拟
and
饱
intensity.
和焦
And
散。
it's a good
如何
way
运行
to
和光
simulate
的形状
complex
这样的一个
lighting,
效果。
and also it doesn't have a lot of effect on the performance.
那么 URP 它cookie 的功能的话，
So
与
for light
现在
cookies,
软件中的非渲染和
it's
SDRP 的一
matching
个
the function
分
of the
SDRP 与
internal
Prepass
rendering
的话，
pipeline
它是功能是
HDRP.
相匹配的。那么它支
So it
持
supports
单重的 ARP
single
和
pass
RGB 的
alpha
不同
RGB
功能格
cookie
式。那么
texture
它支持的光
format.
源类型的话，
It
包括日线
supports
光，包括近光
directional
源，还有
light and
比光
also
源。它
spotlight
支持的光
and
照类型的
the
话，包
point
括
light
实时光，
source,
还
and
有
it
混
supports
合有机
the
位
real-time
三
hybrid
种
and baking.
三种光照类型。那么熟悉 URP 的同
So
学的
if you're
话，它
familiar
应该
with
对这种
URP,
图描是很陌生。
you will
它就
now
是
feel very
它是
strange
URP
to
中
this
的一个
picture
因
because
为
this
URP
is
一个官方的一个案例，一个
a
package。那么它内
URP
置了
official
URP 中的一些
case
学习的实
package.
案例，
It
那么
has a
方便
lot
大
of
家可以
learning
自我学习。
cases
那么相
of
信很
URP
多人其实
inside
从这
so
里
that
啊
you
给
can learn
URP
from
最
it.
大的帮助。
So a lot of
那么
people
我
open
们
the gate
需
to
要
URP
在
here.
Get 上面
So
去
we
下
need
载这
to
个
download this package on Git.
那么现在的话
But
就是
now
那么现在的话，我们不需要去
we don't need
下载
to
和
go
添
to
加。
Git
那么
to
URP
add it
package 就已经
because
内置到
URP
了我
package
们
is already
的一个编辑内部。那
embedded
么 URP
into
package 中
the
还内置了
editor,
大量的一些学
and
习案例。
also there
那
are a
么我
lot
们
of
只需要
cases
按
for
照 URP
learning.
package
We
的时
just
候
need
选
to
择将 URP
choose
package samples 然
uh,
后导入
to
我们的
import
功
the
能
URP
就可以。
package samples during the installation of the URP package.
我们可以看到，就是我们这里面
And you
我
can
们的
see
里面内置
that
了丰富的
in the package
学习案例来
there
供大
are
家学习。
abundant cases
比
for
如
you to
像
learn from.
LTS
For
学习中的
example,
一个
the
摄像机
FPS,
FOV 的一个示范，
FOV
然
modification,
后屏幕空间的一
and
个环境光遮蔽
the
SSAO， 然后波浪的
SSAO,
一些效果，
and
然
also
后
the
包括
glitch
一些遮挡
effect
的一些效果。
and occlusion effect, and so on.
并且在未来的话，我们还
And
会
in
继
the
续
future,
添加
we
更
will
多的
add
案
more
例来增大
cases
你
for
们学习
you
的看到。
to learn from.
OK， 那么新版本中添
So
加
in the
了，
new
这是
version,
另外的一个功能，就是新版本中添加
we
了对
added
深度
the
预通的
depth
深度预通道的一个支持。那么
Prepass
在
support, and in that
智能渲染通道中的话，我们
rendering
所有
channel
的可
for
圈
all
里
of
不透
the
明网格都会
opaque
被
grid,
渲染来
it
填充
will
我们的
be
一个
filled
深度防御值。
with
那么
rendering
深度预通道的渲染
to
结
have
果的话，
this
可以在
depth
渲染
buffer.
不透明的一个
So
物体时候被直接读取，
while
因为使用特色。
rendering the
我们
opaques, it
称
can get
这是一套
called
全新的一
directly.
个方案，
So
叫
it's a
Z
kind of
priming 或
brand
者
new
Depth priming
solution,
深度
Z
引导
priming
或
or
者是深度
depth
启动。
priming.
那么深度启动的话，顾名思义，
So
就是从
for
深度
depth
开始
priming,
渲
it
染方
means
式，从深
it
度开始渲
starts the
染方式。
rendering
我们
with
知道在通常
depth.
情况下的话，那么
We
渲
know
染
that
速度
for
的
the
话
shader, for
会
all of the
根据
passes, they
决定
independently
是否
decide
开
whether
启深度
they
潜
open
入或深度
the
实
depth
只有运行到
writing or
pass 的
depth
时候
testing.
才会
Only when
随之
things
比较
get
迟疑。
run to that pass,
当我们
it
对一个
will
Z
know
priming 的
whether
深
it
度
needs to use
测
it.
试的话，会
But
使
then for Z priming,
Prepass 的一个
it uses
推
depth
深度和
prepass
推深度协同的测试。那么
the
将其他
to
pass
deal with the
的
depth
一个写出
writing
一
and
张
testing,
比较
and it turns off the writing of the other
这
passes.
个方案的话，比较下这个方案的
So
话，可以
if
显
we
著的
compare
减少，
this
就是甚至说可
method,
以消
basically
除
it reduces
几何
or
渲染的
eliminated the overdraw
它的
of
代价是
the
增加了一个 Pass 所带
geometrical
来的一个
rendering.
draw call，
The
所以它计算
trade-off
是
is
比较
just
小。
that
我们
it
看一下
adds
更
a
有
little bit
简
of
单的
draw
一个
call of the depth prepass, so the computing is quite small.
我们可以看一下，在 Z
So we can
priming
see
期间
that
前的
before
话，我们发
the
现在这个渲
enabling
染
of
过
Z
程中，我们
priming
大量的
during
一
the
个
rendering, there's a lot of overdraw.
那么接下来我们打开我
But
们
when
启用我
we
们的 Z priming 之后的话，
enable
我
Z
们发
priming,
现场景中的
the
overdraw
overdraw is reduced a lot.
那么我们来通过一则数据
So
看一下，就是
we
这个案例我们
can
来做。
use this
我们在
case
这里中的
as
话
a
放
sample.
进了一
So
个
in
具有
Unity, we
大
created
量
this
重叠
scene
和
with a
跳
lot
动
of
的一个
overlapping
对
opaques.
象的场景，可以看到。
We can see this,
让我们关
and
闭
we
和开
can
启 Z
turn off
priming
and turn
前
on Z
后来
priming
测试一下
to
两者
test
的
the
一个
frame
帧率。
rate.
那么这里的话，我们
So
在4K
on the
新
in
的建立的一
4K
个
resolution, we use the
4K 建立的
GeForce
一个 GeForce 一个
RTX
2060
2060 Super.
我们可以看到，就是
So
没
when
有
we
开
don't
启
turn on Z
Z
priming,
之前的话，我们这个
it's 45 FPS.
在
If
开启 Z priming 之
we
后的
turn
话
on Z priming, it's 200.
那我们来看一下，我们如何
So
是启用我们的
let's
Z
take a look
priming。
at how we enable Z
这里的话
priming.
，Unity 提供了一个自
Here
动识别的
Unity
功能。
has this
我们
auto ID function to to tell whether the environment supports the priming, and it provides a uh, parameter type parameter to help us decide whether we force on this technology. So when we need to use the depth prepass, we just need to set depth priming mode auto or forced. When it's not on, Unity will roll back and use the traditional shadow map. So let's take a look at some of the new functions. We have the swap buffer system here. Normally, we cannot do blit on the same texture, so for the developers, they need to set a lot of temporary or extra textures. So in the new URP, we want to deal with this on the backstage in a very clean way. So we have this A/BRT system, and then the user can very easily write and read into this object. So from A blitz to B, and then it displays B. So we hides the switching operation, and the user just needs to upload the texture, and then it displays the outcome of the processing of the texture. So using swap buffer, we can realize the post treatment effect like this picture, and then the debug window. In the new version, we optimize the URP scene commissioning or coordination view or debug window so that it's more similar to the internal rendering pipeline options, so that we can check the material attributes and the interfacing with the lighting, how we execute the shadows and LED to form the final frame. URP applies the screen space ambient occlusion SSAO in the renderer feature. SSAO is independent from URP post treatment effect. That means SSAO is not relying on URP post process volume, so it doesn't interact with volumes. The other thing is that in 2021 LTS, URP brings a lot of SSAO improvements. For example, SSAO supports the deferred rendering path, and also the patches is helpful for improving the SSAO. SSAO supports the particle system, and it uses the unlit shader objects, and the performance of SSAO is largely improved. The other thing is that we added this speed tree plant support. For example, for the speed tree wind system and animated plant, we support that as well. So URP uses the shader graph to support speed tree 8. And the light layers can be used for occluding some of the light in the scenes to affect the mesh so that it gets distributed to the light layer, and the impact will only be distributed to the same layer of mesh. So that's it for today in respect of the new functions. If you want to know what kind of new features that URP already supports, or what kind of functions do we plan to support in the future, you can log on, you can visit this website, and it's all open to public. And if you want to know more about what I shared today, because time is limited today. If you want to know more about the detail, so in the Unity Chinese classes, we created some of the courses. It includes the renderer feature and camera stack, and the post treatment, and the occlusion effect, decal system, Enlighten Realtime GI, URP, Deferred rendering path, and how we use the lens flare and so on. And in our resources, we do have abundant courses and classes, and this is the URP plus XR QQ group. If you're interested, you can get in. And finally, let me show you the URP interaction system based demo. we incorporated 4 functions: LTS and map and charging interface and the auto vehicle, the vehicle mounted music player and so on, and the robot. Let's take a look. And for the car model, it has 400,000 triangles, and we benchmark against 8155. CPU occupation is 15. Frame rate is stable at 30. So this is the interface in the editor, and we can see the result on an actual device. Okay, that's it for today. Thank you.